All right, so today what we're going to do is we're going to start continue our look at the pathways, right? Remember, a path is not a circuit. A path is just a line from start point to a finish point, right? So what we're going to do today is we're going to look at how to apply a little mathematics to be able to find the shortest possible path. You're going to see most of these, the shortest path for most of these that we look at today in the beginning is going to be intuitive. And that's a perfectly good way of selecting the shortest path. If you can look at the drawing and do the shortest path, that's perfect. But as we move forward, you're going to see the drawings get more and more complex, so it's going to be a little more difficult to do. So recall those that we looked at last time where you were doing the pathway and it had number values, right? So there could be a certain number of units or a certain number of miles between towns or whatever. That's the kind of thing we're going to be looking at today. And one of the tools that we can use to make these pathways easier to understand and easier to choose the shortest path is by using a tree diagram, which is always your favorite thing, right? So you're going to revisit that a little bit, which can't hurt. Pardon? Yes, pretty well, kind of, but they're not going to be about probability. It'll be about shortest path, but they'll look exactly the same. Okay? All right, so let's just go to the book and look at a few of these. So, first thing you'll see there is the definition of shortest path is simply the shortest path from one point to another. What you need to remember is that you do not have to go through every node to find the shortest path. You can go through as few places as possible, as long as you're finding the shortest possible route. A lot of times these are used for mapping out the shortest possible routes between places, or the cheapest way, the shortest route. And you can have more than one path with the same shortest value. So be careful. That's another reason we use the tree, because you need to be aware that there can be more than one path that has the shortest value. And if you only choose one of them, you're in trouble. Okay? So, all right. So again, you can find it by reasoning. Sometimes these things are so simple, you can just look at it and say, this is it. Right? Like the first one we're going to look at, you're going to just see the shortest path. But you have to prove it. So you still have to be able to prove that it's the shortest path. And most of the time we're going to do that is we're going to look at using the tree. So we're going to talk about the trees today again. You've seen them before, but we'll see them today. All right. Also, on some questions you're going to have to be given some other factors to consider. For example, you might find a shortest path, but there's something that would make that shortest path an undesirable route, right? You need to go through one town to get to your final route, and that path doesn't include it or something. There'll be some restrictions. So watch the directions. Don't just find the shortest path. Read the directions. It's going to be really important for you. Okay? All right. So let's look at a few of these. So here we go. Here's one of the diagrams that you looked at last time. We have a path from start to finish. Just get a bright color here. So our starting point is point A. We want to finish at point H, and it doesn't matter which route you take, and you can kind of intuitively see that looks like probably the shortest path, right? Okay. But you have to be able to prove it. And the only way to do that is by comparing it to the other routes. Notice that there are several different ways of getting to our final point, and you need to compare them all. Now, but I didn't go to everything. For example, this route, none of this route or this route, it's certainly not that one, none of those make any sense, because you'd be going out of your way. Now, unless they told you had to go to a certain point, then you'd have to include that path. But you do not have to include every path in your tree. If some of them are obviously going out of the way, then ignore them. All right? So that narrows your tree down a little bit. So in my mind, there are really only those three paths to consider. Do you see how I came to that conclusion? Okay. All right. So what we're going to do is we're going to create a tree diagram to demonstrate that. And I'm going to do it. I know do it in your book. So remember, you always have a start, right? And our starting point is point A in this case. We have 3 different roads going out from point A. So we'll have 3 different branches. The first branch is 8 units long, second one 11, third one 20, right? And they each go to different places. And so this is where the trees get a little different. So if you look at this first branch here, what is the next stop on this, or the next node on that particular edge? B. So we're going from A to B, right? And then we're going from B to C, and then finally we end up at H, right? So to C to H. So you see the tree is slightly different. It still has a starting point, and it still has a certain number of branches, but then after that, the branches flatten out. It doesn't just branch out several different times. So if we're going from B to C, that's 21. From C to H, is that another 8? Right? And so we have our branch. The name of that branch is A, B, C, H. And then you're going to need a total. You need a name and a total. So how am I going to get a total? Just add them up. So what are you going to get there? 37, yeah? Okay. Get out those calculators. You know I can't add. All right. Now let's do the next one. The next branches off, goes to E, then to C, then to H. So it's A, E, C, to H. So from A to E is 11. From E to C is 13. Just put in the values. Name the branch, or the path. I'm sorry, not really the branch in this case. The path. And what are those going to add up to give you? Anyone? Y'all going to make me do all the math? 2432? Okay. All right. So you can see that these tree diagrams are very easy to make. Now we're going to do one more. And that's from A to F to H, right? Has the fewest turns, but we'll notice when you put in the numbers, from A to F to H, first one's 20, then you have 18, so that gives you A, F, H as a value of 38, sorry. Okay?
For that one, in the book it says that when you go to B, you can also go to E. So if you go A, B, then E as a third.
You could, but
do you have to do that?
no. Because if you think of it, look at that trip. If you went to B to E, right, which is the center, you're adding in pretty much a detour, right? Can you see that one is not?
Only one more than B to C.
Yeah. So you can include it, but it's not going to be the shortest path. Okay? But you can certainly include it. They just said it looks like one of the shorter ones, so they put it in there.
But it only goes to E. It doesn't finish.
Okay?
No, it does.
All right. Yeah, they didn't finish any of this. So it took three times for them to do it. They were doing each one independently. So if you look at their diagram, so they started at a common starting point, and then they showed every point that might make sense. And then they did another diagram here with another set of steps. So they eventually got there for all of them. But they were doing it in pieces just to show you. And of course, the one with the smallest number is the shortest path, and make sure you label them. And when you're doing a pathway, the notation for a pathway, what do they put between them? Arrows, because you're going from one to the other. All right? So you need the value and you need the name of the path. Sound good? Think you can handle it? That's all we're doing. So,